Hello everyone, welcome back to Dragonfly Engineering. So this week we've got part 3 in probably a 4-part series where we finish the mold that molds this white plastic lid. And this lid is interesting because it's got a couple of hinge posts that stick out. And these posts were created using cam actuated side pulls or core pulls in the mold itself to create this perfectly round post here and one that's right there. Also in this mold, we've got some A-side pneumatic ejectors instead of the traditional B-side or the moving side of the mold. So these I'm going to show briefly how these were assembled as well to eject the part off of the A-side of the mold using compressed air. So I hope you enjoy. Thanks for watching. Okay, let's get this mold assembled. So you probably saw in the voiceover how I inserted these side pulls, which will basically pull out to create a little undercut plastic boss here on this plastic part. And we got two of them. So there's a 40 or a 30 degree hole, like a cam hole in this side pull insert, and then a 30 degree back angle to help push this part towards the closed position. So we inject plastic in the closed position when the mold's closed. And then that angle pin, which will actually exist on this side of the mold, which pierces this hole. When the mold opens, that 30 degree pin will cause this hole to follow that pin and cam action open like so. The amount that we have an undercut, which isn't very much, it's about that much distance. So I'm going to stick our cam blocks with the cam pin on the B side of the mold. Okay, so here's our cam block. This is machined out of A2 tool steel, and we've got a 3/16 guide pin right here. This is that cam pin that fits into the little hole in the slider. And there's also a wear plate, which I basically just found an old machining parallel and cut it into a square, put a lead in kind of fillet at the top so that we can start the angled side of this side pull, which also has like a broken edge fillet so that we don't have any like sharp edges that hit and clunk before the back slider of this side pull engages on this wear plate. Whoop, engages on this wear plate here. So yeah, that's the profile. And I just basically sanded that in. And yeah, so the back of the slider basically fits into this region where the cam pin opens the part, or opens the side pull up when the mold opens. And then this heel block and wear plate pushes the part and clamps it shut against the shutoff in the side pull of our part itself. And then on the bottom I've got just a 1/2 inch 13 big thread. And I'm actually going to utilize on the, oh, and we've got two of these, by the way. And I'm going to utilize the ejector pin, or the return pin for the ejector that would have operated on this mold if we didn't do an A-side eject. But these holes I'm just going to use to basically anchor our heel block into this machine pocket using the 1/2 inch bolts, these guys, and a washer, and basically reuse or use the unused return pin holes to anchor our heel blocks in place. So hopefully this fits in. And this pin is retained by the countersink, and then actually I can show that to you. So this pin here is just an ejector pin where I ground off most of the foot of the ejector pin, and then there's also a chamfer that was ground in that matches the face. So in this, the base face of this heel block. So when this heel block is inserted into the mold, an aluminum face will couple up with this ground in facet and basically keep this pin in the right position. So let's take a look. So we'll stick our heel block in, like so, and that's seated. And then from the back side, I'm going to use this 1/2-13 bolt, and we are going to use our through hole here to anchor our heel block into place. It's not going anywhere. There it is. Okay, I'll do the other side and I'll be right back. All right, so the moment of truth. We'll see if all of this actually fits together without too much interference. I think I'll get a little oil and pre-oil our side poles. One nice thing about these wear plates is that I can undo the screw and then add shim behind the wear plate if I need to adjust the travel of the side pole that is engaged with this surface to the wear plate surface. So that's kind of handy. So we'll give a little oil here. This is just whey lube, nothing special. And I've already pre-lubed these shafts. I'll give them a little more. And also lube up the guide bushings on the B side. Clean off the scraped edge of our mold. Or the crud from the table that I just scraped up. All right, this may be hard for you guys to see. So yeah, we got our little cam block here and our side pole slider here, and those need to nestle together along with the rest of the mold features. All right, so we got the main bearings engaged. So these sliders will be in the out position when the mold opens. So what we need to do is line up the little guide pin to the angled guide hole, and then see that the back bearing part actually lines up to. Maybe I'll get the GoPro. Okay, I got the GoPro here. This may help with visualizing, so you can see down that gap, hopefully. Now this is the heel block, and then this is the side pole. And you can see how our pin and our guide hole need to line up. Maybe you can see that over here too. So I will close the mold and see what happens. All right, so we hit a little bit on the back of the side pole. Now I'm going to tap the two together. Looks like our cam pin engaged on both of the holes. Hopefully you can see down in there. And you can see here how the little pin engaged with the cam hole. And then on this side, you can see similar. So hopefully this closes with basically no gap. And there's some gap. So we got to figure out what that's causing. All right, I got to find the source of that interference, so we'll figure it out. I'm going to tap it a little bit, see if I can find an impression of where the problem is. There we go. Now I got to debug and figure out where the interference is. So this could take a little bit of time. Let me start off with some obvious things. 11.68 is the height of our heel block. The heel block clearance is taller than that. All right, so I'll put a piece of paper in here. All right, got our paper in there. I'm going to tap on this again, see if we can find the source of our problem. Okay. Well, it looks like I've got interference. You can see right there on my piece of paper, I got some interference on basically the front of the side pole is, I think, hitting the machined out clearance on this side of the mold, hence the two holes right there. So I need to machine away some more, and I'll probably see some indications in the aluminum there of it trying to get plowed out or forged out. And yes, I do see a step there which was basically cold forged from where I was hammering to find the source of the problem. So I'm going to stick this mold back on the mill, and I am going to machine off a little bit more of that clearance. So another thing I can do is remove these wear plates and see what happens there. Well, it's safe to clear out this clearance stuff here, so I will do that. Yeah, because this slider is actually travel limited by its heel, which stops at a machined edge, which defines the perfect location of the rest of this structure on the actual cavity itself. So when the mold is coming in, this edge right here, which is a clearance for all of this mechanism, is hitting and gouging. So I just need to take probably like 3/4 of a millimeter off of this surface and this surface. So I'll do that and we'll be right back. Yes. All right, let's see if that fixed it. I'm sure there's going to be some more little fussy things to deal with. Usually I wind up having to fix some things after the mold is fabbed. If I spend forever fussing in CAD, I probably could catch some of these things, but you usually can't catch everything. Unless you blow your budget on a whole bunch of CAD design. All right, let's bring it together. All right, so the side pole's engaged, and yeah, we still have something going on. All right, well, I need to figure out where this approximately 1.5 millimeter interference is now. So I'll probably iterate this process a few times to just bring it in using the piece of paper as a feeler. And we'll get there. So now I'm taking off the wear plate here to see if I have over-constrained the travel of the 2 side pulls, and if I have, then I can surface grind off some of the back of these wear plates to fix our fitment problem. Because I still have this pesky like 0.8 millimeter gap in the 2 molds, which you don't want to have. So let's see what happens after I remove the wear plates. I think that, well, no, there's still a gap. So it's not the wear plates. Huh. I think I'll leave the wear plates out for now until I find the final source of our interference. So I'm putting blue tape on features to see if I can find the squish that's resulted from a impact. Ooh, that was loud. Yeah, it's a very small gap now. Huh. I see a couple of little bits of aluminum on that tape. You may not be able to see it, but there's right in the corners I see some impression. All right, I think I finally got it. So I put the wear plates back, these little guys, and I found what looks to be the last evidence of any interference, and it's all around this, where the side pole interfaces with this side of the mold to seal off the cavity. Just a lot of little fussy things, like small differences in vertical dimensions. When you do a 30-degree angle, that adds up to a big mold gap. So it kind of amplifies your tolerance problems when you multiply by basically, what is it, sine or cosine of 30. So, but anyway, let's see how we're doing here. All right, so that closed pretty good. I still see a very slight gap, like maybe a sheet of paper, like 100 microns or so. But I'm just gonna let the molding machine figure the rest of that out, and it will seat all the parts and then make the ultimate seal, basically. I mean, if there's a huge gap and we tried that trick where the molding machine fixes your mold, then you'd break something major. But with such a small gap, it's just gonna find its seat and probably have to friction open the first time, but then after that it'll kind of coin itself into shape. So I am going to put the back on this one, and this one is effectively finished. So, oh, and I got to put the air ports in, or the air connections for our A side pneumatic ejectors as well. And this is the nozzle input, and that's about it for this mold.